Think math.
There are 3 doors. Behind one is a car. Behind the other 2, goats. You pick door 1. Then the host, who knows where the car is, swings open door 3, revealing a goat. And he asks, would you like to switch to the remaining door or stay? 2 doors remain, so it feels like 50-50, right? Surprisingly, no. Switching wins 2/3 of the time. Staying wins only 1/3. Switching is exactly twice as good. Here's why. Your first pick holds the car with probability 1/3. The car is somewhere else with probability 2/3. But the host knows the answer, and he only ever opens a goat door. If your door is wrong, the remaining door must be the car. So that entire 2/3 piles onto the single door you can switch to. Let's check every case. If the car is behind door 1, staying wins and switching loses. If it's behind door 2, the host opens door 3 and switching wins. If it's behind door 3, he opens door 2. Switching wins again. 2 cases out of 3. Switching wins 2/3 of the time. Still not convinced? Make it 100 doors. You pick one, and the host opens 98 goat doors. A single door remains. Would you switch? Of course. Your first pick was right with probability 1 in 100. The remaining 99 out of 100 are all sitting on that last door. The moment the host removes a goat, the odds stop being even. They tilt hard to one side. Switch, and you win 2/3 of the time. Stay, just 1/3. A slice of math every day, here at Think Math.